Good day, everyone out there in YouTube land. This is Solar Steve from Solar Nation, bringing you the first off-grid demonstration video, and this will be the overview of the off-grid Outback system that I posted about 18 months ago. As you recall, I kind of showed you this equipment as I had just bought it, and certainly it wasn't installed, and at that time I kind of did a real quick overview. But now that it's all been installed, I really wanted to start a video series that describes each component, what it does, why it does it, and why it's important. Not to mention some of my design philosophy that went into picking these components. Certainly, we also will be covering this on High Voltage with Solar Steve on www.thewatchman.fm Saturdays and Sundays from 3 to 5 Pacific. And we will be taking your calls and your emails at solarsteve@thewatchman.biz. All right, let's get on with it. Basically what you're looking at is a FlexWare 500 power panel from Outback Power Systems. That's the gray portions that you're seeing in front of you on the left and right side. In the center you see the two black inverters, which are Outback Power Systems VFX 3524 inverters, simply meaning that 3500 watts continuous on a 24 volt battery system. There are two of them, which means that I am allowed to run this in a 240 volt mode, or I can run them in parallel, or in series, excuse me, on a 120 only system. We will go into the specifics of that later. Off to the right here, you see the charge controller and the mate. That is an FM60 charge controller, also by Outback Power Systems, and the mate, the beige colored oval that you see on the wall, and that is the control interface where I can change my programming. I can look at the settings, look at the status of all of the devices as they are operating. Moving over, here are the batteries that are currently attached to this system. This is a very small battery bank, guys. There's only 4 110 amp hour 12 volt batteries that have been wired in series and in parallel to produce a 24 volt battery system at 220 amp hours. All the wiring has been done with 4/0 fine strand welding cable, and you can see that the terminals are in fact pretty beefy. And of course the battery wires continue across to the DC side of the power panel, which is where everything, all the DC components are wired into there. And on this side is where all the AC components are wired. Okay, currently the system is off. The charge controller is on, but we're kind of getting some rain today, and so they're really not producing much. But this is the overview, and in the following videos I will be taking each component separately and devoting a full 10 minutes to each component, so that you have a complete understanding of what's involved here, how it works, why it works, and what it takes to have a truly functional off-grid power system. Now, this system is designed to work in absence of grid power. However, you can hook up grid power to it, where it would facilitate battery charging in the event, say, the solar panels are not sufficiently illuminated to make enough power to recharge, or to rapidly recharge off of a generator. That is certainly one way to do that. There's only, well, let me take this off the tripod real quick. We're gonna unclip from the mothership here so that I can show you. These are 5 Kyocera KC130 solar panels that are all wired in series to produce about 95 to 100 volts direct current coming into these wires, which then come into the building up here at a junction box. And you'll also see that gray cylinder looking object, which is a lightning arrestor, so that in the event that I did have a lightning strike on the panels or on the roof, that it would clamp that voltage and would prevent it from continuing downstream all the way across here and then into the charge controller. Now, as we can see right now, we are producing some power. The batteries are completely full, and it's in float right now. But certainly it has 4 different charging profiles that it will use depending on the state of charge of the battery. These up here is incoming and outgoing grid power into the AC side of the box. And you can see the breakers that control the flow of alternating power, either whether it's grid power into the inverter, and outgoing power, which connects it to the rest of the residential wiring system. Here's what one of the inverter status indicators looks like. There is a bit of a glare. I apologize for that. And you can see that these are in fact absolutely beefy. One of these inverters alone weighs about 50 pounds. This whole power panel weighs close to 175 pounds. So it is certainly not a lightweight thing by no means. And of course, coming over to the DC side, we can see our main battery breakers for each inverter, 250 amps. And then you can see the charge controller breakers that with the flick of the switch, I can turn off the solar panels from the charge controller, and I can also turn off battery power to the charge controller. So that's basically it in a nutshell. Now, right now, like I said, I have 5 panels on here for about a 650 watt nameplate amount of generation. But these over here, these are 4 more panels that are left over from my grid tie project, and they will be going up on the roof as well, wired in parallel with the other string, which will give me around 14 to 1500 watts at around 95 volts. It should work out very well, and in fact it will be maxing out the charge controller when I do that. Very nice. Outback comes with a lot of manuals. If you can see how thick that is. We have a manual for the charge controller. We have a manual for the inverters, the hub communications manager. There's the mate and the programming guide for the mate, programming manual for the inverter charger, installation, and the charge controller. So as you can see, I've organized this stuff into a binder for reference. And typical tools of the trade, I really like Fluke. It's probably one of the best meters that you can buy. And when it comes to accurately doing this and making measurements, you really need quality tools that you can rely on as far as accuracy goes. Okay, so this is Solar Steve for now with the Outback Off-Grid Overview, Part 1. The part coming up next will be the inverters themselves, and we will be going in depth on how they work, what they do, why they do it, and what makes Outback the leader in off-grid power. So for now, Solar Steve, we'll see you guys later. Thanks for watching. And don't forget to catch me at www.thewatchman.fm Saturdays and Sundays from 3 to 5 p.m. Pacific for my high voltage show where we talk all things off-grid power and preparedness. Thanks, guys. Thanks for watching. We'll see you later.